So welcome back to another exciting edition of Unfiltered from IED Countermeasures. In this version of training that we're going to provide for you today, we're actually going to be talking about lower edge cutoff with portable x-ray systems. And the reason that we're going to focus on this topic is because it's pretty obvious from a training perspective and also from the vendors is that they don't have a fucking clue what they're doing. And we're going to show you a ton of examples of this, and this stuff really needs to be stopped. Now, how I know from personal experience that the bomb community, especially bomb disposal, are not aware of this is the fact that in the United States, I see all the technical specifications that come out on their solicitations. So any bomb squad in the United States that's looking to purchase an x-ray system are going to put out technical specifications they require of that system to make sure they can perform their mission as a bomb squad here in the United States. And I've discussed this before, pretty much across the entire spectrum of what I've seen is absolute shit that's coming from these bomb squads and whoever's running their procurements. And almost 99.9% of what you're seeing is a vendor specification that they simply cut and pasted from that vendor's website. And these guys, you guys are not doing market research. They don't understand the technology, so it's just absolute. It's an abomination when you look at it from trying to get the best technology for your team and making sure you're getting the best price and all kinds of things. So in this one, we're going to look at lower edge cutoff and explain to you what you should be asking for when you're looking at a portable x-ray system or what types of things you should be looking for. And then more than that, when you actually have a system, there are ways that you can try to reduce the lower edge cutoff that you're going to experience. And again, this video is going to explain a lot of that for you. So the first thing, or the one thing most people know and think is the only real reference to lower edge cutoff or the dead zone at the lower edge of the panel is with your digital radiography panels, especially the amorphous silica ones. Again, I've told you before, these are freaking medical panels. They can have a lower zone, and if you're scanning on the ground, this is where it becomes very important because that lower dead zone is not going to get imaged in your x-ray image. So whatever's in the package that's below that is potentially not going to get imaged. Now, the first iteration of these panels that came out were straight up medical. We're now starting to see with the medical manufacturers that they're buying these from, that they actually produce a NDT, non-destructive testing, or a security type panel. And these panels will typically have a much lower bottom dead zone on the panel. Now, the range you're going to see, or about the best you're going to see, is around 3 millimeter. And from an engineering perspective, based on how these are designed, they really can't get any lower than that in regards to how low they can actually get. I mean, it's just basically from an engineering side, they can't get the scintillators and the detectors down any lower that inside of the casing. So if you're looking for a detector panel and you want to make sure you've got the lowest lower edge dead zone as far as this product specifically, you want to look for something that's below 5 millimeters. So if I know all the different products that are out there on the market, if you see anything that's above 5 or 6 millimeter, that is a fucking medical panel, okay? Because they don't give a shit about lower edge dead zone because they're not scanning with the panel sitting on the ground or with the package sitting on the ground. They're scanning a person standing up or laying down, chest x-rays, hand x-ray, what have you. So they don't care about these dead zones. It's not relevant to them. But to us it is, because we have a box on the ground, we're placing our panel behind it. That lower edge dead zone is going to cut off part of the image. You want to limit that as much as possible. Now, everybody seems to think if the panel's at 3 millimeter, that's what you're going to get in the image. No, that's not it. Okay, that's just part of what creates a lower edge dead zone. So the panel is one aspect of that. So what's important is not the panel's dead zone, it's what you get in your fucking x-ray image. Remember, I don't give a shit what the technical specification is on a piece of equipment that's part of your x-ray system. What matters, what fucking matters, is how it correlates to your actual x-ray image. So with lower edge dead zone, just because it says it's 3 millimeter, does not mean you're going to get 3 or 5 millimeter in your image. There's another factor that you have to take a look at, and that happens to be the height of your generator off the ground, okay? So when you take something like the XR150 and you place it on the ground, and then you have your panel, okay, with it also sitting on the ground, it's basically a straight line, okay? This is the best way to look at this psychologically or in your head. Draw a straight line from the lower part of the aperture where it produces the x-rays to the lower edge dead zone of your panel, okay? And anything that's underneath that line, okay, is not going to show up in your x-ray image. So just think about this. If I take this x-ray generator and start raising it up, that line is going to get higher and higher in correlation to the bottom edge of the imaging area on your panel. That's how the shit works, guys. Okay, that's a very simple concept, and that's how it works. And I'm going to show you a ton of examples. If you understand this basic fucking principle, you will never raise your fucking generator off the ground. It is biblically stupid for ground scans, okay? Absolutely fucking ignorant if you're raising your generator off the ground and your panel is sitting on the ground along with a package. You're going to massively increase that lower edge dead zone. Don't do that, okay? So the lower this is to the ground and the lower your dead zone and your panel, those two in combination is what's going to show up in your image, all right? That's what's going to show up in your image. So there's a way that you can test this and verify, all right? There's a way you can do this. And we created, and then we actually do this in our advanced X-ray interpretation training course. When they run practical exercises, what they do is they run this box, which is a lower edge cutoff test box. So I want you to look at the back side back here. The first thing I have in here is this little guy right here. This is called a fiducial. So with this fiducial, we're going to actually measure it. We know that it's a 25 millimeter fiducial. So you'll shoot this box and you'll place it with this back end against your panel. You'll shoot this box, and the first thing you'll do is you go in your measurements and you'll measure this fiducial and put it in at 25 millimeters. Okay, bam. Now we've calibrated our measurement to an exact known fiducial. That's what a fiducial is. It's an exact known reference. Don't use batteries and shit and all that other kind of crap because they're never the same fucking size. Trust me when I say this. You could go pull up the spec sheets on batteries and look at the sizing on there. They are not the fucking same, okay? They're not all the same. Now the measurements might just be off just a little bit, but that little bit matters when you start looking at the grand scheme of things. Now the next thing you're going to do is you're going to measure this battery, which is up elevated from the lower edge of the panel, so you're going to be able to get a true top to bottom measurement of this battery. Okay, so now we know what that battery is, and we have the exact same make and model battery all the way down at the lower edge of the panel, at the bottom of the box. So when we get the difference between this measurement and this measurement, that is your lower edge cutoff dead zone. How much is getting cut off in your image, okay? In your image. Now, when you do this test, I want you to elevate your generator, just for the fuck of it, okay? Elevate the generator and watch how much that lower edge dead zone is actually going to increase because you raised your generator, all right? And the other thing it's going to do is also increase the dead zone coming out from the panel. This is where it gets worse. So we've got two other references, one at 10 centimeters away from the back of the panel and one at 20. And then as your dead zone as it starts coming outward from the panel, it actually starts increasing, okay? This is why it's so fucking important. It's not at the panel, which is potentially going to be a problem, which it could be if you're like the guy in Florida asking for an 8 millimeter fucking dead zone. I mean, below that, when you got your generator and your panel at 8 millimeters dead zone, you could miss almost an entire fucking 9-volt battery on that one. That's fucking stupid, okay? So on this one, with these two batteries out here at that extended distance, you're going to get a real good idea of what's getting cut off as you start moving out from the panel. So again, combination of the panel's lower edge dead zone and the height of your X-ray generator. So the next thing we want you to do is when you do this test, when you first get those measurements, back your generator up farther, okay? You'll see a slight reduction in your lower edge cutoff, okay? But it gets to a point where you're not going to see anymore. It's basically, it is what it is. It's the physics. It's basically, again, you have a dead zone in your panel and you have a certain height of your aperture of your X-ray generator off the ground, which is going to correlate into a dead area. Plain and fucking simple, all right? So the next thing that we're going to do is when we do this test, you also have at the end of it, at the very end of your box, just go and place some typical IED components that are in a circuit, and then see if that outer edge, that going that far out, and this one's at about 27 millimeters. I suggest doing the test all the way out to about 30 centimeters because that's kind of the typical size of your box. And this right here is a perfect training scenario for your unit. You can build this box very easily, and you can sit down and do x-ray training and teach all your guys so they fucking understand what lower edge cutoff does by either elevating the dead zone on the panel and elevating the actual generator. This is perfect stuff you should be learning or being teaching your guys in your unit. If they're not teaching this at HDS, they need to fucking start teaching it at HDS, okay? It's a fucking simple thing. All right. So there's other things that can contribute to lower edge dead zone. And these are all things you need to think about when you're actually taking an x-ray, but also when you're purchasing an x-ray. So all of these digital radiography panels, if you go to the websites of the actual manufacturers of the systems, you're going to find that the hospitals all have what we call drop insurance because these things are fragile. I'm sorry, guys. I don't give a fuck if it's IP67. IP67 has shit to do with me dropping it on the floor. That's called a drop test. And the ANSI 4255 and the NIJ standards for the United States have the most ridiculous fucking drop testing requirements in there because the fucking vendors wrote them, okay? So with these panels, to pass a drop test, trust me, they have to have protective armor. Now this is Novo's protective armor. This isn't a bad idea if you're doing a scan off the ground. But if you're doing a scan that's on the ground, the package is on the ground, do not put on this fucking protective armor because you're going to massively increase your lower edge dead zone. And on this one, you know, I can't see what the measurements are in their website, but any vendor that's using armor, that armor is going to increase your lower edge dead zone by an inch or more, okay? So never use fucking armor on a ground scan. It's stupid, okay? Also remember that the only way they pass a 1 meter drop test is with the armor on. So unless you're going downrange every goddamn time with the armor on it, your drop testing needs to be with the armor off, okay? And you need to make sure of that in your solicitation. I never see you guys asking for this shit. Most of you don't have a fucking clue. So there's other things that can actually potentially cause this lower edge cutoff. And again, we told you this is going to be the actual generator height, how high your generator is off the ground. So if you take a typical Golden, this is the XRS3, you have a certain height that's just built into it that's going to be a tribute to your lower edge dead zone. There is a way to mitigate this, and you can take the Golden and lay it on its side, and it will reduce the lower edge dead zone. So when you're doing this scenario with the test box, one of the things you should do is then show them by laying the generator on the side how you can reduce that lower edge dead zone. It's slightly effective. That and distance are about the only things you can do with the generator as far as reducing that lower edge dead zone. Now when you look at something like the CP systems like this one, it's already about half the distance lower than an actual Golden X-ray. And if you take this rubber protection thing off on the side, it actually gets it lower to the ground. So again, a generator that's the lowest to the ground is going to give you the best reduction in lower edge dead zone when you take the panel and the generator attributes together and look at it. So again, there are some things that the vendors do that make you scratch your head and go, what the fuck are these guys thinking? And it really makes you understand how ignorant the fuck they are about X-ray in general and how it works in your mission, your actual fucking mission, okay? So one of the things we saw a while ago, and we're seeing them all get away from this, but some of the vendors were taking their control box. So a lot of these systems, these ASI panels, if they're kind of shitty engineered, like they just use the Wi-Fi in the fucking panel, or they bought one of the panels that don't even have a Wi-Fi and they're hardwiring it to a control box, that's your communications hub. And those are the lower quality engineered systems that you're looking at. But one of the things they try to do is to fucking stick it underneath the generator. This is just fucking stupid for ground scans, okay? If you have one of these and you're using this attached to your generator in this configuration for a ground scan, you're a fucking idiot, okay? There's no ifs, ands, and buts about it because this is drastically reducing your lower edge dead zone. Now, there are things out there that the vendors will sell. They'll put like a protective sleeve that goes over the panel. This one is actually from SmartRay, and I've actually tested these panels. So these sleeves actually will raise the panel up off the ground a few millimeters. So it actually increases the lower edge dead zone. So I don't know why they have this plastic thing on it. I mean, I guess maybe it's not waterproof or something. I don't know. But these sleeves actually will increase the lower edge dead zone. When you start getting into the CR systems, the phosphorus plates, like the ScanX Scout or the Dura CR35, they come in a protective sleeve typically, and that protective sleeve will actually also potentially increase lower edge dead zone. With the ScanX system, they have a thing called the FlexRay kit. That fucking sleeve, if you're using it, it massively increases your lower edge dead zone, almost up to about a half an inch or more, depending on how you got that panel sitting inside there. It's pretty bad. So typically with CR, if you're just using the plate, you have no lower edge cutoff at the plate. But when you start putting it in these sleeves or putting inside the FlexRay, you are going to increase the lower edge cutoff of those items, all right? Some of the other things you'll see, and here's a perfect example of drawing line from your X-ray aperture to the bottom of the panel's lower edge dead zone. And then you can see right here at the bottom, that part of the item that you're scanning, and depending on how far it comes out, is how much of that is actually going to be cut off. This is the biggest reason why you want to really look at what type of factors technically in your generator, your procedures, and in your detector panel you need to make sure you're aware of to lower that lower edge dead zone for you guys on your team. Now there's other things out there that can also like significantly reduce lower edge dead zone. And here's one where they're using the generator on a tripod. Okay, on this scenario, this is just fucking stupid. Okay, there's no reason for this. No reason for this whatsoever. If what you're x-raying is on the fucking ground, your fucking generator needs to be on the ground. And if you're not doing that, you don't fucking understand x-ray, and whoever trains you is fucking sucks, all right, if they taught you this shit. Now here's one. This is from XTK. This is the stand they use for XTK. No, okay? I'm sorry. I mean, XTK is a pretty cool software. Their grid aim system is awesome. But if you can't fucking see it, you can't fucking shoot it, okay? So when you have this thing elevated like this, now you can lower that stand a lot lower, but it's still going to drastically increase your lower edge dead zone. So you guys at XTK apparently don't understand fucking lower edge dead zone, and you need to unfuck this, okay? Because this is not helping the guys in the field. It's a serious disadvantage to this fucking system. And it's just stupid. I mean, anybody who does fucking x-ray should know this basic shit when it comes to lower edge dead zone. It's not fucking rocket science, all right? There's other products out there that when I see these, I kind of have to scratch my head. But I'm going to do a whole nother video on these ones. So this is like a slider, all right? And this one is a basically 3D. It's shooting at different angles, and it can do some other stuff. Different vendors have these, but you know, I'm not picking on these guys, but the reality is you've elevated your fucking generator, and you're going to have lower edge dead zone that's going to drastically be increased because you've done this. Period. Okay? No ifs, ands, buts about it. It increases the lower edge dead zone. Where I see this shit a lot, and I sit there and go, what the fuck are these people thinking, is on robots. The most stupid x-ray shit I ever see is on goddamn robots. It's like, I don't understand what the fuck's going on, but it's obvious the two vendors have got together and said, hey, let's merge our shit, and neither fucking one of them have a fucking clue how to take an x-ray. Because then you start getting stupid shit like this, okay? Look how high that generator has been elevated off the ground, all right? And they don't give a shit if your panel's on the ground. When your generator's like this, your lower edge dead zone is going to be fucking pretty significant when you're trying to x-ray something. It just shit doesn't work. It doesn't make any fucking sense. And as much as you guys might not like C-arms, there's a right way to do C-arms. You're going to do another video on that one. C-arms are the best fucking tool in the world. But on your goddamn C-arm, your panel touches the ground, your fucking generator touches the ground too to reduce that lower edge dead zone. Here's some more examples that when I see these, I'm just like, what the fuck? And I don't know what it is with you European guys standing up your pipe bombs. Do they fucking, and I've asked this, like, do they stand their pipe bombs up in Europe or some shit? Because here in the U.S., they don't stand up like that. So when I see this shit, I'm like, what the why is it out in the open? Why is it in a package that's just stupid? And then I got this one right here. The fucking generator's way the fuck up here. This is so not gonna work. I mean, you're gonna maybe x-ray the top half of that bag. And when I see this and I'm going, who the fuck is doing that? They're an idiot. These people behind this image right here are all retarded. They're just fucking stupid. They don't understand x-ray in the slightest. This is just biblically dumb. Here's another one, another perfect example. You see this shit a lot. Chassis mounted on the robot. It does not work. Use a fucking C-arm. There's a right way to use a C-arm and a wrong way to use a C-arm. They work better. And don't try to carry the fucking C-arm in front of the robot to the target. That's fucking stupid. I don't know why you guys try to do that shit. It's absolutely dumb. So again, this was your short video on lower edge cutoff and how to actually train to improve, and also what the things you need to be looking for when you're actually buying a system. You know, asking for titanium backscatter fucking protection or load bearing weight. What the fuck? Load bearing weight? Seriously? You know, ask for some shit that makes sense in your solicitations and buy a unit for a system for your unit that's going to provide them the best capability. And it starts with knowing your shit. Okay? It starts with actually knowing your shit.